So now let's think about the steps for hypothesis testing when we have groups. Okay? Here is the independent sample z-test for a difference of two proportions. Okay? The idea is we have two proportions, right? And we want to make a hypothesis test. We want to really say something about a population. Okay? When we talk about an independent sample z-test for the difference of two proportions, right, the main condition is that there must be at least 5 successes and 5 failures for each group. Right? This is again an assumption about the population. Okay? In general, it means if we have a larger sample size, we can be more confident that this condition holds. There are 5 steps which we've covered before. The tests are very similar. You calculate the test statistic, you assume the null to be true, and you can make a conclusion based on a test statistic or p-value. Right? We also have the z-test statistic for the difference of two proportions. Right? This is for two independent sample z-test with a two-sided alternative. Okay? So the z-test statistic has this particular form. The idea is that the point estimate here is just a difference, okay? Because a difference is a single number. So that's the basic idea. Instead of looking at a mean or proportion in a sample, you're looking at the difference as your single point estimate. And then the null is that that difference is 0. Right? Because if the difference between the two proportions is 0, then there's nothing going on. So the basic idea is the same. Right? You take that point estimate, that difference in sample proportions, you subtract out the claimed value of the null. So for this course, we're just going to focus on a null of 0 and a two-sided alternative. You divide by the standard error. The standard error is a little bit more complicated, but it's really, in essence, just a reflection of the two sample sizes and the fact that we have two population proportions. Functionally, it's the same kind of form. The idea is that we have the z-test statistic, which tells us how consistent or inconsistent our data is from the null hypothesis. Right? Again, we typically don't know these values of p1 and p2, so we might use the sample proportions, p1 and p2, when calculating the standard error. The z-interval for the difference of two proportions is given as follows. Okay? It's a similar kind of process in which our point estimate is it's the same as before, really, when we had one sample proportion, except the point estimate is now this difference. Okay? The standard error is calculated in a slightly different way. We can substantively interpret this confidence interval in a similar fashion. Right? Besides comparing two sample proportions, we can also conduct an independent samples t-test for the difference of two means. This is where we have two sample means, right? And we want to kind of look at their difference. Okay? The steps are the same as before. We're going to use the t-distribution model because it's a more sort of general form, and it's really the appropriate distribution when we're trying to model the sampling distribution for the difference of two sample means. But we can construct a confidence interval, and we conduct inferences and make conclusions using the test statistic, critical values, and p-values. Right? We will use statistical software for the two-sample independent t-test. In this course, we will assume that the null is 0. By far, that's the most common assumption in the literature. And we will also assume that we're focusing on a two-sided alternative. So the alternative hypothesis is that the true difference in population means is not equal to 0. Again, that's because in the published research, that's by far the most common alternative, a two-sided alternative in which the difference in means is not equal to 0. So we can see the statistical software will give us the means of each group, the sample means. And we can use a p-value approach or a test statistic approach. Again, we're going to use statistical software for this, and you can use p-values or you can interpret the test statistic if you're given a probability distribution. In this case, the p-value is 0.05, which is greater than our conventional level of statistical significance of 0.05, so we fail to reject the null hypothesis. And with that, we've covered the basics of inferential statistics, from the central limit theorem to how we could model and understand the sampling distribution using the normal distribution model and the t-distribution model. And we've also talked about various one-sample tests and also comparing differences between sample proportions and sample means to try to say something about differences in means and proportions in the population.